All right, everybody, thanks for coming. Once again, we have Ken Sharp. You might remember him from his last talk on that was automation related, and this one is also automation related. Ken has a YouTube channel with some cool automation stuff on it as well. I'm really excited about this because he's talking about Home Assistant, which I've been meaning to get into, but just already have enough hobbies apparently. So looking forward to it. Hope you enjoy. I've got some IPA here from beer that you want me just to pass it around?
Sure.
Like anytime?
Yeah.
Or, okay. So help yourself.
Yeah, and there's Baltic Porter also. It's like the last of my keg. Hopefully it hasn't,
Okay, you
aged too far.
Oh, is that one right there?
Yes, that
Okay.
one. Yeah. So that's, yeah.
All right, we'll just send them around. And this is being recorded, so it'll be on the club YouTube channel as well.
Yep.
All right. Take it away.
Don't do anything stupid.
Yeah.
Yeah. Take it easy
There's
on the
for
F-bombs.
posterity. I don't think YouTube cares about this. All right. Hey, thanks for coming. So this is basically my latest contraption. It's gonna kind of sound like a love letter to Home Assistant as we get further in this, but well, anyway.
Have you used Home Assistant for other things before this?
Yeah, I started using it for actually home automation stuff, and then I was like, hey, this might work really well for beer stuff, so that kind of went off. So yeah, a couple disclaimers on that. So yeah, I just kind of launched a YouTube channel. There's a video series on basically, this is going to be basically like an overview of this fairly long video series that I made. So I will probably repeatedly being like, I have a video on this topic in depth. So sorry if you get tired of that. And I'll talk a little bit more about the YouTube channel kind of at the end. Let's see, other disclaimers. Yeah, I was actually going to bring the fermenter here, and I realized like just before I came here, it's like 3 or 4 inches too big to fit in my car. So there's a lot of pictures in here. Sorry, I wanted to actually have it here, but oh well. Let's see, other disclaimers. So I'll probably like list off some prices of parts and things as I go. I'm gonna kind of just say off the top of my head what they were when I bought them. Now, a lot of the things came from China, so they may be more expensive now. I don't know, we'll see. Yeah, that's about it. So, let's get going. Okay, just super briefly about me. Yeah, I graduated from Purdue, like half the people in this room. Yay. Yeah, so I've been in test and measurement for most of my career. Mess around with home automation, obviously I brew, and I'm a kind of terrible hand tool woodworker as well.
You have a hat like that?
No, but I think my woodworking will improve if I can get one like that. So, might be investing in it.
You gotta get a mustache too.
Yeah, but yeah, I need a bigger, bushier one, I think, for sure. Okay, so basically the project today that I'm going to talk about is taking a low-ish cost fermentation chiller and adding a bunch of electronics to it, basically. So the design I chose here is a pretty old one from '95, I think it was first published, called the Son of a Fermenter Chiller. I don't really know why the name is what it is, but anyway, but I basically took this design exactly as it was presented. The big kind of takeaway from this is
Is that yours? Really?
yes, mine is on the left.
That's the best.
The one on the right
one
is a computer render of it.
Yeah.
So I'll kind of talk through how it works. But basically, this closes up on the top and the front. There are ice bottles that go kind of in these 2 slots. And I use 2-liter bottles. Some people use milk jugs. Some people swear by laundry detergent bottles because the plastic is thicker. Eventually, the bottles will split and just from repeated freezing, so I just keep extra 2-liter bottles on hand. So it does require a freezer. This is not like a complete solution in itself. I I have 4 or 5 2-liter bottles in my garage fridge.
Unless you live in Indiana in the winter.
Yes, that also works, but then you probably don't even need to use this. So that's kind of where the cooling power from this comes. So this is kind of an overhead view. These chambers, you can stack up to like 4 milk jugs in these things. I usually just use 2, one on each side. And what happens is this is a little fan here, little PC fan. And basically when the temperature gets too high, in this chamber where your beer is, it will turn on the fan and basically pull air from that chamber through these baffles, past the ice bottles, and kind of spit it back out into the chamber where the beer is. And it sounds super simple, but it is surprisingly efficient. And I've probably done like 6 batches or so with this thing, and I've been pretty happy with it. What I've found is it can get the temperature down about 20 degrees below the ambient temperature. So if you're in an 80-degree garage, it can take it down to about 60. If you're at that kind of maximum though, you're going to be changing those ice bottles probably every 8 hours. So it's going to be kind of a pain. So doing like lager fermentations where you're at the kind of bottom of the temperature you can get to is kind of a pain in the butt because you just have to swap ice bottles for like weeks. So I for ales I found it's like ideal. I can usually swap ice bottles about once every 24 hours and it does a fine job. It keeps the temperature pretty accurate, I think within about a 1 degree. So that's not a problem. Yeah.
That's I mean, having been around in the 90s when a lot of people were using the same style, whatever, that's the cleanest one I've ever seen in my entire life. Usually they're like some salvaged styrofoam that was through a war and,
Yeah.
out of 3 houses and nest of wires and like, that's super clean.
Well, that goes into my next slide perfectly. So I brought some samples. Basically, this whole thing can be made from 1 4-foot by 8-foot sheet of foam, 2-inch thick foam. The quality of the cuts as you cut these things apart matters a lot in how good it looks in the end. It'll probably still work if you do a crappy job, but you just have to be a little careful. I brought 2 samples of foam. So part of the reason mine looks so clean is that at the time, I don't know why, it's not like this now, but there are like 2 types of foam that you can buy at Home Depot or Lowe's. This stuff that I used is this, and it's the same, it's made of little tiny spheres. You can actually see kind of like chunks of it will come off. So this stuff kind of sucks, but I use this because this stuff, which is extruded foam, which is much more solid, was like twice as expensive. It was like $80 for a sheet of this stuff, and it was only like 30 or 40 for this at the time. Now the prices are a little closer. So I use this because I'm cheap, but I also, because all the edges were this rough crap that kind of comes apart, I basically covered all the edges with this duct tape. It's not actually duct tape. It's like foil with adhesive on the back of it that is used for ducting.
Yeah,
Yeah.
it's actually the real.
It's a real
Right, exactly. So I use almost like a whole roll of this, like covering all the edges, so that there are basically no exposed edges of this crappy like stuff that comes apart. So that is just to show, like, if you want to cheap out like I did, you can actually make this kind of crappier foam work. So it's up to you. But this stuff is definitely better. So if you can afford this, or
And there's a third kind of foam, there's like the isocyclone, whatever. It's usually foil bound too.
I'm not familiar with that one.
Yeah, if you,
Is it
like,
solid like this stuff, or?
It's solid, not quite as solid. It doesn't quite have as high a pressure rating if you were to like stomp on it or whatever. But and that's actually higher R value per inch but I don't know if they make it, like, it might max out an inch and a half, inch or inch and a half.
Oh, okay. Yeah, you really need 2-inch for this
Yeah.
stuff, for it to all kind of work out. And I think this stuff is
But
definitely like
you do 2
heavier.
layers, you could do 2-inch layers though, and like do the offsets, if you
could-
bond it,
yeah,
whatever.
you could, yeah. So yeah, definitely doable with that too. This stuff is probably, I think it might be a slightly smaller R value, but in practice, it doesn't really matter. It's a very good insulator. So for cutting it, I recommend a blade like this that has that you can get like 5 or 6 inches of a really thin kerf blade. And you can kind of see, that is actually me cutting it. If you can kind of keep it 90 degrees and cut it like with as few strokes as possible, like you get a nice clean edge. And this matters more if you're using the crappy foam. The extruded stuff is a little more forgiving for kind of cut quality.
Could you cut the extruded stuff if you had like a bandsaw or something? Probably with that.
Yeah, maybe. I think it might
Or would it-
it might shred the edge of
Okay.
it pretty badly, so you might end up with an
You
even
still need
rougher
a
cut.
slow kind of.
And I don't
Yeah.
know, I don't know if it would work with that foil line stuff, but there's also like those hot knife ones, or people like, you know, take your 12-volt battery and the
Yeah.
right wire and you can,
Yeah, no, that would be the cleanest cut. This is pretty good just because like you're really using just the fact that this is razor sharp and you're, you know, trying to cut rather than the bandsaw blade. I think would just tear too much.
yeah.
Yeah.
I suspect. I haven't really tried it,
That's
but
I was just thinking bandsaw's got a pretty small curve.
yeah,
So
the
as
kerf,
well,
the
so-
kerf would be good. I think it's just the teeth would
Yeah.
shred worse.
Yeah.
I think I did kind of try it, just a handsaw on it a little bit, and I think it had the same effect. Like it worked, but it made a really crappy edge, just because this stuff is so soft. So, oh yeah, and so for putting this all together, the thing you want to use is construction adhesive, or like name brand would be Liquid Nails, that kind of thing. Some glues will dissolve this stuff. Construction adhesive will not, and it is super strong. So, I don't know of any fasteners that would work with this stuff because screws would just tear through it. But you don't need anything like that if you use construction adhesive. It's super strong. There were a couple of places where I tried to use like super glue or some other things, and they eventually failed, and I ended up going back to construction adhesive in every case. So I think I ended up using like, you know, like kind of a standard tube that would go in a caulk gun. I used the whole tube for
Did
this
you
thing.
strengthen the area where you set your carboy in, like underneath, or?
Nope.
Or is it just set it right on the foam?
Yep, and it will dent it slightly, but it's very slight. So yeah, I just put it right on there.
Watch out for those high gravity.
Yeah, that might do something.
Hey, question, maybe you get to this, I don't know, but you mentioned the thickness of the ice container, and then some people like the thicker walled ones,
Mhm.
which tells me that they're trying to slow the melting of it, so that they don't have to change the bottles as much.
I think it's not so much about the rate of melting. I think it's more about just that the freeze thaw cycles will rupture the.
So they're less
Any-
likely to crack.
Yeah, because they're a thicker wall, they crack less easily.
I just wonder if that affects the heat exchange efficiency.
It probably does, but I don't. In my experience, it hasn't. I mean, I haven't tried thicker. Well, no, I did once. I did use some of those like cooler pack things that you can, like, that are much thicker plastic. It didn't seem like there was a significant difference in, like, you know, how much or how quickly they melted or how much cold air they produced or whatever.
When you said your system is plus or minus 1 degree, which that could be your temperature controller. So it sounds like you're like right at,
That's true.
like you're not suffering for any
Yeah.
efficiency at all. So there might be some wiggle room there for like a more insulated container that doesn't melt as quickly, so you don't have to change the bottles as much.
Yeah, I think it would work with a lot of different vessels. I think the only problem you would have is if you had something that was actually like like insulated. I don't think it could basically pull enough cold air. Well, it would probably work. It just would work more slowly, I think. That's kind of a guess, but educated guess.
Do you think if you had a non-insulated, but like a metal container,
Mhm.
the heat, you know, because heat transfers better through metal than it does through plastic,
Mhm.
you think that the ice inside would melt quicker, but you would have better heat transfer?
You'd have
Yes.
less cycling because you'd have colder air.
Yeah, I
Because
think,
the surface, really, the air is going across the surface of the container,
right.
or, you know, there's heat transfer between the metal and the air, or the plastic and the air.
Mhm.
Because
And so-
that'd be the same thing, I mean, my thought is why just the 2 bottles, why not, I mean, I don't know how much space, but why not put, 6 bottles?
Yeah,
Not have to change it as often, because you're probably not losing a lot of heat outside of there's some, I mean, that insulation's pretty good.
yeah, I think the fan would just turn on for a smaller amount of time. Like the better the thermal conduction was for whatever vessel. And the reason I put 2 in there is mainly because if I just put 1, I have to change that 1 ice bottle more frequently. So it's mainly just laziness. If I put 2 in there, it
Are these gallons?
Roughly
half gallons, or
doubles.
2 liters, or?
2 liters is what I use. So I do 2 liters in there, and that usually gives me easily 12 hours. And towards the later stages of the fermentation, and also if the ambient temperature difference is lower, I can sometimes get like 24 hours or more out of 2 bottles. And it's roughly half that if you just use 1. So
I would suspect during active, like high Krausen fermentation, you're changing them out much
Yes.
faster than you would be as you get to your final phase, because the heat of fermentation is
it's significant.
pretty significant
Yeah.
in the most active phase. So.
Yep, and you can see it. You can see it very easily because, yeah, I have to change ice bottles about twice as fast for the first couple of days
Yeah.
of fermentation, and it produces a lot of heat. So yeah, you're absolutely right.
It's probably, I mean, that heat, I always wonder, like Sun King has got those, whatever, 120 barrel fermenters outside. Like, it's those things, as I understand it, like, you go in at the right temperature, and there's, like, or you're cooling them, or whatever, even when it's 20 degrees outside.
Mhm.
So
Yeah.
much heat.
Yeah.
Yeah, it's a surprising
They're
amount
not
of heat.
stalling out fermentation, they're outside.
Yeah, I've also experimented a little bit. Like a lot of times, I'll let things free rise during the active phase. But if you try to suppress it, like or cap the temperature at a certain temperature or whatever, it's difficult. It'll chew through ice bottles really fast if you're really trying to suppress that heat rise. So it's kind of interesting from an experiment standpoint just to see kind of how the yeast
Yeah. I mean,
operate and stuff.
I've done a similar thing with a water bath
Mhm.
with ice in it, ice bottles in it, and running almost like a glycol system,
Mhm.
but using water. And it was the exact same thing. It was first 3, 4, 5 days you're throwing ice bottles in every 5, 6 hours, and then
Yeah.
when you get to through that active fermentation phase, it's like once a day maybe.
Yeah, it's very similar
Yeah,
with this.
okay.
Yep. Cool. Oh, I should mention too, all the foam, construction adhesive, all that stuff, I just got at like big box stores. I can't remember if it was Lowe's or Home Depot, but similar. Yeah, so the only changes that I made to the kind of stock design from 1995, besides the electronics, is I added magnetic catches. So the designs that I saw, usually what they do is they basically drilled holes through the top and the sides, and they would stick dowel rods through there.
They didn't have
And-
magnets back.
Huh?
They didn't have magnets back then.
Yeah, 1995. No
I don't
magnets.
remember
Yeah.
magnets anywhere.
Well, that's what I was like, man, that seems, I don't know, archaic. So I was like, I'm gonna try these nice little cabinet magnetic catches,
Fantastic.
and they work pretty well. So I think I've got 8 on, like 4 for each panel, like the top and the side. Much better, in my opinion.
Cool.
And then I also use the fermentation CO2 to purge my keg. So I basically made a little access hole that I run a hose through, which you can kind of see there, and I just stuff a rag in to kind of fill up the space in the hole. So.
And you want your hole up high,
Yeah, well,
with the
yeah.
fans off, you can lose more cool.
Right, that's about the top of my fermenter, or where it is. So it was that was just kind of a natural spot so that the hose would kind of go into the fermenter in the right place and all that stuff. Actually, I think I'm going to move that to the side because it's a pain. Every time I take that door off, I have to like disconnect the hose. And that was a bad idea, so I'm actually going to move it. Yeah, and of course, the electronics is really where the magic is. Okay, there's the electronics. Got it? Are we good? Okay, cool. Yeah, so this is just two views of it. This is just an eye chart. But one's a breadboard view of how kind of look in the real world, and then the actual circuit schematic, a crappy one. Okay, but now let's talk about the actual pieces of the electronics. So this is a Node MCU. It's just a little, it's basically the brain of the operation. It's a processor and a Wi-Fi radio all in one little package. I got this off of Amazon. They cost in the range of $2 to $3 a piece, so they're inexpensive.
Now at 155%.
Yeah, so I don't know. Like, I think Amazon, they're still going through their current stock, so the prices are still the same, but I don't know.
It depends on whether it counts as a complete computer, because those are
Yes, I actually read the changes on that to see what category printed circuit boards would be under, and you can read it in a way that it's exempted.
It's interesting, right? Because technically that
Yeah.
qualifies for the exception.
Right.
But if you look at it, like somebody looking at it who doesn't know what it is would say, no, that's a component.
Yeah. Well, and all the news articles, they're like, oh, chips, like bare chips, and computers and smartphones are what's exempted. But I actually like went in and I kind of read, and it's like, I think if you read it right and kind of squint at it, it sounds like stuff like this is exempted too, I think. But I'm not a lawyer, so I don't really know.
So does that mean BMW is gonna ship my car in parts and I have to assemble it?
Yes. You'll save a bundle, so, yeah.
Maybe. I've seen you assemble stuff.
We don't want to go to the
Depends on how many beers.
So yeah, I'll get to how this all kind of plugs in. The hardware here is not really, I mean, this really just defines the capabilities of the system. The software is where it actually does something. So, and we'll get to that. Okay, so this is the fan that I mentioned before. This is just a very straightforward PC case fan. I think it's like a 120 millimeter size, I think. So these are on the order of like $10. You can get fancy ones that have like RGB LEDs and all this crap if you are into that. But just a basic one is like $10 or so. And then so the Node MCU works at very small voltages, like 3 volts. It can only handle like 15 milliamps of current, which can barely light up a little tiny LED. So it cannot run a fan directly. It will just burn itself out. So you need something in between the brain and the fan to help with that. So this is a relay module. Again, off of Amazon. This is probably, I don't know, $2 or $3 as well. And basically the very low voltage, like the 3 volts from the Node MCU goes in this side, and it turns on this big fat relay here, which is really just an electrically controlled switch. That's all it is. This one can handle, it takes like 3 volts to turn it on, and it can switch, actually, wait, I can read it there. 250 volts AC at 10 amps, or 10 amps at 30 volts DC. So, AC, DC. alternating current, which is what's in the socket in your house, direct current, which is what like smartphones and everything else use. The wall warts that you plug into one convert to the other, that kind of thing. None of this is using AC, but I could totally hook up, you know, a lamp or a say refrigerator compressor like into this side, and it would turn it on no problem. I think, yeah, 10 amps would probably be enough for that. So anyway, this does the heavy lifting of routing all the amperage for all this stuff. That fan, I think I measured it at one point. It doesn't use much. It's like 150 milliamps or 250 milliamps, something like that. So it's not too much, but still way more than the Node MCU can handle on its own. Okay. All right. So here's the temperature sensor. So this is what will tell the Node MCU what the temperature of your beer is. So this is a little one-wire temp sensor. These are super common on Amazon. This one's actually in a little stainless steel waterproof thing, so you could actually put this in water if you
Anybody
wanted to.
wants one, I've got like 20 that I'm not using, so just put it out there.
Yeah, it's nice just having a pile of these lying around. The cool part about these is it requires one pin on that Node MCU to talk to the sensor, and you can actually hook up like, I forget what the limit is, but you could hook up like 30 of these to one pin on the Node MCU, and it could read temperatures, like 30 different temperatures at once. So if you wanted to stick a bunch of temperature sensors in different places, you can totally, these are great for that. And again, these are, I don't know, in the range of a couple bucks a piece, something like that, maybe $3. So. Okay, and then the last thing, this is optional, but I added one because why not? Usually you just use Home Assistant, which I'll be getting to interface to this thing, but I also thought it was nice, you know, while I'm messing around with it, that I have some little display. And so I just set this up so it shows me the current temperature here, and then the set temperature, or the desired temperature here. So, and that just updates dynamically all the time. Just a little visual indicator. I think this LCD was probably $5, 5 or 6. Let's see. Okay, so now let's get to the fun part. Home Assistant. Okay, so Home Assistant is an open source project. I think it's actually like the most active open source project on the planet at the moment. I think it even beats out the Linux kernel, I believe. So anyway, really active. It is free. It works shockingly well. It's pretty easy to set up. This is actually a screenshot of my home dashboard here, and
Fermenter's not on there.
yeah, I'll show it. It is. It's just further down. It's over here. I need to make like just a beer dashboard, like separate one, but
Resolution
yeah.
too small to encompass
Yeah.
Kevin's entire home assistant setup.
Pretty much. And there is a really good phone app for it, and it looks pretty much the same as here, just, you know.
So can you go on a 60-second detour of what you're using it for non-beer?
Yeah. So I've got my Ring camera. That's basically my Ring camera set up here. I've got a couple of lamps in my family room that are here. In my garage, I have another little Node MCU that's just has a temperature and humidity sensor, so I can tell what's going on in my garage. You can see some of the fermenter stuff here, but not the actual like thermostat stuff, which I'll show later. But in my basement, I also have, oh, that's just off screen too, crap. I have a radon sensor in my basement that like I can tell how radioactive my basement is all the time from Home Assistant, which is cool.
Yes, but can you increase radioactivity?
No, I cannot, not yet. I can work on that.
And what like kind of sensor are you using for that, and what does that cost?
So the radon one it's really hard to find just radon sensors on Amazon, so I couldn't really build my own. So I think it's an Air Things is the brand, and it's a little box about this
Got
big.
some communication protocol that.
Yeah, and it communicates over Wi-Fi. So it's just a commercial thing, but plugs into Home Assistant just fine.
And then you got some automations, things happening, make other things happen.
I will get to that too. Mostly just for the fermenter. I haven't really done much automation stuff with my house as a whole, surprisingly.
Could you, if you had like, say you wanted to turn on and off water valves or something, could you do that with this system if you had electronic valves?
Yes, yeah.
Okay.
And that's gonna be my next slide, is you can basically make custom devices, you can do whatever you want. Anything you can find a sensor or an actuator to do, like a valve, you can control it with Home Assistant.
Keg runs empty, turn on a light, turn on a fan, turn on a
Yeah.
valve to refill.
I was thinking like, you know, you had a little sensor at the bottom of your hot water heater, and if it sensed,
Moisture,
you know,
shut it
moisture,
down.
it would, shut the water off to the house or something.
Yeah.
There are leak, there are
There's commercial.
leak and moisture sensors and stuff, like
Yeah.
Tara has some really good ones, and if you,
You can also make one, I did this because I wanted to put one under my water heater, which it's not actually set up at the moment, so it's not on the dashboard, but 2 stainless steel screws that are not connected to each other. Put that on the ground under your water heater, and you can make yourself a little leak detector, and it works shockingly well.
You know, it'd be cool if you put a CO2 sensor in your kegerator, if it spikes above a
Yeah,
certain, you
got a
got,
leak.
you got a leak and you could shut off your.
Yeah.
Yeah.
I have a couple of ideas around that. One is, well, the easiest one is you can put a little leak sensor in the bottom of your kegerator,
Okay.
so you can know like, oops,
Yeah.
sprung a leak and there's beer.
I have one of those.
Yeah. So yeah, and you could totally plug that in here, set up automation, so it'll send you a nice phone notification that your beer is leaking on the floor. So yeah, the sky's the limit with this stuff. It's
Cool.
It's awesome. But yeah, so I'll get to the custom device stuff in the next slide. But yeah, Home Assistant as a whole, though, it's really easy to set up. I have a video
And
on
so-
setting it up.
So is it just like 4 devices? Is it like a library of plugins that has the protocol? Like there's a lot of with all
Yeah.
the development
Yep.
stuff going
So
on.
it's super pluggable. Like there's like, I forget, like 1,000 integrations is what they call them. So if you have like my little Air Things radon sensor, right? There was an integration that I added to Home Assistant that knows how to talk to Air Things sensors.
And everything's probably has their own app, but you're consolidating stuff in.
Right, but this integration knows how to talk to it even outside of the app.
Yeah.
So yeah, there's integrations for almost everything. There's a few things like the MyQ garage door openers. They explicitly lock their stuff down so that they would not allow Home Assistant to use it, which pisses me off.
Yeah, but
So there's a few like that.
There's a lot of garage
You
doors.
need the RAT GDO.
Yeah, and which by the way is based on the same
Yeah, I
processor
have
that I
one.
just showed.
I have one and it works really well, but I use it,
I've been meaning to get
the home kit, the Apple home kit.
Oh, okay.
Kernel or whatever it is, flat, like, firmware. for
Yeah.
it. But you can get Home Assistant firmware
Yep.
for it too.
Yeah, there's ESP Home.
Right.
That's on my to-do list is to get one of those. By
Yeah.
the way,
Yeah, let me know.
because my
it's great.
queue,
Yeah.
I hate them now. But yeah, so getting started with this, my kind of I tried to find the easiest way to get going with Home Assistant. You do need a Home Assistant server running at your home to do this. They actually, in the Home Assistant community, there's like a foundation, I think, that is like the kind of legal entity behind this. They actually sell products now, and so this little box here is called a Home Assistant Green. It's $99, or at least it was last time I checked. And the out of the box experience is awesome. It's pre-installed with Home Assistant. It updates itself. It's really great. So I had been using like Home Assistant on a server, which is kind of a pain in the butt to set up, but totally possible. A lot of people use it on Raspberry Pis because those are fairly inexpensive. I now recommend this Home Assistant Green because it's not much more than what you would pay for a Raspberry Pi with power supply and all the other gadgets that go with it. And it's so easy to get up and running, and I've had this for about a year, I think, and it's super reliable. So I really like it. So I have a video on basically kind of like an unboxing and how to do the initial setup of Home Assistant on this device. Yeah, I think that's the main points. Any questions so far?
So this device can replace Alexa and all those other
Yes.
commercial things, so I don't have to give Google and Apple and all those people my, it's like
Yes.
attached.
And actually, thank you for bringing that up, because one of the big points of the Home Assistant project is their whole thing is they like you to keep your data private, like local to you, and not being used to serve ads to you by Google or Amazon or whoever. So one of their big mission statements is keeping your data private, and they even have ways that you can kind of like get some of these commercial devices off of the device's clouds and just controlled completely by Home Assistant within your own home Wi-Fi network. So they're very big into that. Kind of the voice side of things that like you like talking to Alexa or whatever. That's kind of the bleeding edge of what they've been doing. They actually now have a little like kind of Alexa or Echo equivalent device that can do voice stuff. And it's getting more and more sophisticated. Like they're putting a lot of effort into making it as good or better than the Google and.
Is that
Amazon
running
stuff.
locally then?
Yes.
Wow.
So.
Ish.
There's you can run it completely locally. They also have a cloud service that they offer that that you can pay a little bit extra and you get a bunch of benefits. One of which is you can kind of use their cloud infrastructure to do like machine learning or kind of like LLM stuff. That's like a whole other topic, but they've been like rapidly innovating on that stuff lately. So that's pretty interesting too. But
What's your YouTube channel called?
I'll get to that. It's Brewski Tech, which is kind of a weird name, but yeah, I'll have it at the end here, and I'll talk a little more about that too. Okay, so let me back up a second. So there's an add-on. So Home Assistant is super pluggable. There's an add-on which you can kind of see over here called ESP Home. Now they've renamed it ESP Home Builder. And basically the whole point of this thing is to make custom devices. So a lot of, nobody sells a Home Assistant compatible fermentation chamber controller. So ESP Home is designed to help you build that. So basically, and it's actually like my favorite thing about Home Assistant by far. It makes it so quick and easy to just whip up a device to do whatever you want. Like in probably 30 minutes, one time I was curious about how much light some part of my yard was getting to see if I could, plant some plants there or whatever. So I just whipped up a quick device with a light sensor, stuck it out there, and had it measure like how many hours of daylight I got, in that spot in the yard. Because it only took me like 20 minutes or something to like whip this thing up. I had a friend who is actually working on the YouTube channel with me. He had a problem where his furnace was shutting down every once in a while for unknown reasons. So he whipped up a quick device that had a couple of temperature sensors, like on the air intake and on the output. And then I think he also stuck a temperature sensor on like the blower motor. And then I think he also had something that would tell him when the motor was being turned, or the blower was being turned on and off. And he basically used that to get all these nice graphs, and he could see like, oh, in certain conditions, the motor was like overheating and going into a reset mode. And so then he was able to like change a setting on the blower motor so that that didn't happen anymore. And he just, again, spent 30 minutes or something just making a custom little device that did that because he needed it. So Yeah, this is awesome. So, and this was also kind of the reason that he and I started the YouTube channel. Was we were like, well, okay, so electronics plus brewing is like a niche that seems underserved. Like, I haven't really seen many other websites or YouTube channels or anything like that. And we wanted to make something that was approachable to like non-engineers, like if you don't want to have to write code. And basically ESP Home plus Home Assistant is the way that you can make custom devices and not have to actually write code. So it makes everything like way more approachable. So instead of having to learn to program, you can skip that part, and then you just have to learn to like plug in sensors and node MCUs and stuff like that, which is maybe easier. So yeah, but the whole idea with ESP Home is create custom devices, and then those will talk almost out of the box with Home Assistant. You can add things to your dashboard, and it's all running on some little cheap device that you bought off Amazon. So the way that you actually configure it, so this is kind of the magic part, and this is a snippet of, like, this isn't the whole configuration file, although it is most of it. So each device has a like a text file that kind of defines what sensors and actuators are attached to the processor. The main point of it is basically telling it like what pin numbers. So you can say like, I'll give you an example here. This fan power section here this is literally the thing that turns on the fan. And it's hooked up to pin D5. That's it. So now Home Assistant can turn on and off that fan. That's all. The temperature sensor, slightly more involved, but basically that's kind of this block here. And you're basically saying, hey, I have a one-wire temperature sensor hooked up to pin D4. The pins are actually labeled in really small letters on the device, so you can actually kind of see where it is. And then I'm saying, hey, update that temperature every 5 seconds. So that's it. This is really, really, really well documented. They have some of the best documentation I've seen on the ESP Home website. So, and they have examples for every sensor that they support. It's kind of amazing, the project. This over here is probably the most complicated thing you'll see in ESP Home. This is the thermostat. So the thing that actually controls the temperature. There's a lot of kind of extra stuff here, like default values and other crap, but the main points here are right here. This is saying, hey, for the sensor, for the thermostat, use this thing, the temperature sensor that you hooked up here. And then when you need a cooling action, like when you need to cool, turn on fan power. And when you don't need cooling, when you're idle, turn off fan power. That's most of it. The rest of this stuff is, it's kind of like if you use like an Inkbird controller, you can go in and change like a bunch of those settings that are like, you know, deadband and how many minutes to wait before it turns on the compressor and all those sort of parameters. That's basically what all this extra stuff is. So, and there's a lot more than this, so you can really like tune it. Like you could very easily take this setup and turn it into a kegerator controller.
So are you programming that in the Home Assistant to say, here's the range, when to kick in and when to kick up, your minimum and maximum temperature? Or is that reading it off your thermostat that's on the cooler that you put? And so as it's, you know, are you programming the cooler and it's reading the configurations off your cooler? Are you configuring it here and the cooler is that adapter is saying, here's the temperature, min, max, and stuff like that? What's the relationship between that device and your code here?
Yeah, that's a good question. So, actually, let me go to the next. This will maybe help to clarify that. So this is what happens when you're done writing your YAML file, which is all within the Home Assistant interface. Like it just pulls up you click on the device, it pulls up that YAML file, you type in whatever you want. When you're done, you hit this install button, and then a bunch of stuff happens behind the scenes. So it basically analyzes that YAML file that you wrote, and it generates C++ code, behind the scenes. You don't have to ever see it. In fact, you probably won't even know that it's there. It uses another really cool open source project called Platform.io under the hood. But it generates code, compiles it, creates a binary, and then it basically sends that binary to the device. It writes it to the device. The first time you do this, you have to use a little USB cable. So you hook up the device to your computer, and it uploads it. The reason for that is it doesn't yet, like the little Node MCU doesn't yet have like your Wi-Fi credentials and stuff like that. So it's not on your Wi-Fi network yet. So you have to give it those credentials, and the way you do that is by doing your first upload via a USB cable. As soon as you do the first one, you never have to use that USB cable again, and any updates you make or changes will go over Wi-Fi. It'll just update it. It's kind of automagical. It's great.
Static address.
So yeah, now the cool part about this is that thermostat that we configured in the YAML file here. That's resulting in code being generated to control the temperature that's actually running on the device. So if your Home Assistant server goes down or your Wi-Fi network goes down, it doesn't matter. It'll just take the last set temperature that you gave it from the Home Assistant dashboard, and it will keep maintaining that temperature forever, as long as it has power. And it doesn't need Home Assistant to do that, because the code is running on the little Node MCU. Yeah. And that LCD is like read-only. It's just telling you whatever the set point was, or the last set point that it got, and the current temperature. So you could actually add buttons to it and actually allow you to, bump the temperature up and down locally on the device. I didn't go that far because I didn't feel like it, but you could totally do that with this too.
All right, so you downloaded the code into your little board that's on your fermenter, and so it runs them in a federated mode, so if you got it. That's
Yep.
pretty cool.
Yep.
Maybe I'm getting ahead, but he also has like capability of doing curves and crashes and programming that stuff. I mean, you could get there, obviously.
Yeah.
Are you doing that yet?
Yeah. So, yep. That's a good lead in. Wait, I think, is that my next?
Just here for the second.
One more slide, and then yeah, it's like you're a plant or something. Yeah.
Make sure you pay them.
So this is what it actually looks like. How you would set the set temperature. So this is just a little kind of generic thermostat thing. This is the set temperature, and you can just hit plus or minus, change it to whatever you want. This is the current temperature, and you can turn it on and off. So right here too. And that's basically it. So that's what, if I had scrolled down on my dashboard view in that previous slide, you would see this. There's a couple of settings you have to enable, but you can actually make this work outside of your local Wi-Fi network. So if you're sitting at your desk at work or you're on a beach in Tahiti, you can actually pull up your phone and change your set temperature wherever you are. Or just see what the temperature is, which is cool.
Time out for describing the beer. What do we have?
What's up?
What do we have?
Oh, that's
and was
my-
it fermented in that?
Yes, it was actually. Yeah, that's my Baltic Porter. That's like the last of the keg. So hopefully it's still palatable. But yes, so that's the only time into the presentation is, yeah, I actually did ferment it in that contraption.
So, why couldn't you use a fridge instead of an ice box?
You totally could. And I think the
first
Sure,
question,
if you got
yeah,
if you've got a
$100
fridge,
or $2 to
or
throw around.
Yeah.
the first
Could you
question,
build, like,
the question.
the
Let me ask the
chamber
question
on
to go
the
before that.
front of
The
the
first
fridge?
question is, why can't you just use a $15 Inkbird that you flashed with your custom firmware, which is like what I've done, or whatever.
Or
it's
just
not
the
an
temperature
Inkbird.
controller I
Because,
already have?
but because of, this is the same question I asked Charlie Bamforth when he gave a speech on like, we're gonna ferment this beer with 2 yeasts, and we're gonna get all these, and I was in the front row like you, and I was like, well, couldn't you just like ferment them separate and then blend them? And he's like, first looks at me like, what the fuck? And then was like, it's
for like, it's for science and fun, man. It's for the experimentation.
But like, so like I have a mini fridge and
Yeah.
I ferment one keg in there at a time. Could I build like a chamber and like seal it up to the front of the fridge and then use that as the cooling
Yes.
Yes.
cycle
Yeah,
essentially?
there's diagrams.
Yep.
out
Any
there.
way that you can pump
And-
cold
and
air
there's-
into
and
it.
Yeah.
there's- Done that. Lots. Martin does that 100% with his fermentation chamber. Where he just has a tube coming off of his freezer with a fan or something. That,
Yeah, and the only change you'd have to make is instead of having that little relay module with the fan, you would instead basically hook up the power to the refrigerator
Yeah.
through that
Yeah.
same relay, basically.
Or you can
And
keep your or you can keep your fridge running and just have a gate or a fan that moves that cold
Yeah.
air, especially if you got like
You
a,
could do that
a
too.
little up in their thing at all. Not the cold won't fall.
You can just string the temperature probe inside the fridge.
Because how did you do yours when your freezer died? Or one freezer died,
Yeah,
you
but that-
hit the other freezer?
I didn't have any
Is there
luck
a
with
way
that,
to replace
honestly,
it
with
with
the
a
ducts,
probe
like
with a tilt?
ducting and blowing it, it was, yeah.
That's more complicated.
it is, yeah, the answer is yes. It's more complicated, so, yeah. Yep. Okay, and here's another kind of part of your question is why the hell are we doing this? So there's more. Okay, so,
Wait, there's more.
but wait, there's more. So yeah, so it's cool. You have a little dashboard and you can control your fermenter from your phone. That's great. But
The silver one.
you can also add automation. So that's a kind of a key piece of Home Assistant. Usually people use this kind of automation functionality to do stuff like, hey, turn on your front porch light when it's sundown, or I don't know, like or like your water heater example, you know, send me a text when my water heater leaks or stuff like that,
Friends
right?
at the front door crank down the beer temperature.
Yeah, or people do stuff like they're like when I'm within 1 mile of my house, crank my AC up, you know, stuff like that. So all sorts of pretty complex automations can be done with Home Assistant. So I came up with 2 useful automations to use with this fermenter. If you come up with some other ideas, tell me, because these are the only 2 like useful ones I've come up with so far. But I'm not that original, so tell me if you think of better ideas. But the first one is, I basically have something that will tell me when I need to change the ice bottles. Because before I was setting a timer on my phone that would just be like, oh, every 8 hours or whatever, go check the ice bottles, and that sucks. So this will actually tell me when it's melted. And the way I figured out how to do that is basically so all the automation kind of rules that you can add in Home Assistant have this form. You set up a condition, so that's this when part here, and then when that condition is met, there's some action that you can tell it to do. There's also an optional like additional condition you can add. I didn't need it for this particular rule, but that's there too. So this is how all the rules are. And there's just a ton of conditions and a ton of actions that you can do and mix and match and do almost anything you can imagine. So in this particular one, I figured out like if that fan turns on for more than 20 minutes, that basically means the ice bottles are all melted. It's not getting enough cold air. So when that happens, I basically send a notification to my phone that says, hey, dummy, change the ice bottles.
So there's something that can send you an SMS then?
The way this works is, there's probably a way to get it to send like a bare SMS, but actually it just sends a message to the Home Assistant app.
Okay.
So I get a little notification and a little sound and all that, but it's within the Home Assistant app.
So it's interesting. That's a good way. 20 minutes. Because I mean, you could have a second sensor, put it on.
I was just
another
gonna say,
chamber,
if the
whatever.
fan's on and the temperature's not cooling, maybe that would be a way to do it, but.
Yeah.
Temperature out of range.
Yeah,
But
there's-
Not
yeah,
down
if
on
the
the
fan's just
side.
been on for 20 minutes.
There's definitely more sophisticated ways to do this.
That's
And
pretty.
the only problem I've had with this one, it works pretty reliably, except when you first put the fermenter in there, and usually I'll put the beer in there, and it usually needs a little additional chilling before I want to pitch. And when I do that, when it's bringing it down like another, 5 or 8 degrees, well, it'll stay on for longer than 20. So I'll put it in there and I'll turn it on, and 20 minutes later I'll get a notification that says, hey, change the ice bottles, and I just know, like, yeah, ignore that, it's fine. Other than that, it pretty much, every time I've gone down there to check the ice bottles, yep, they're melted, and I swap them. So this one works pretty well. So the next one I came up with is the temperature ramp. That one's, I'm not kind of showing the contents of it. I have a video on all on this, but this one's even more useful. So basically I set this up so that it would reduce the set temperature of the fermenter every so many hours. Like, so every, let's say, 8 hours, it reduces it by 1 degree or something like that. So I can do like a slow temperature or a slow cold crash over multiple days. And I don't have to remember to keep changing the temperature. It just does it automatically. And it will also, you can set like a floor. So you can basically say like, okay, ramp it down, 1 degree every 8 hours until it hits, 45 degrees or something like that, and then call it quits. And so that, I use this like every brew now, and it's awesome. So
So that's a lot of ice, so I guess, to bring anything down.
yeah, it depends on the ambient temperature in the basement, and so sometimes I'll only have it, I'll only bring it down enough so that the yeast is kind of dormant, and then I'll throw it in the kegerator basically at that point. But it depends on the beer, and it depends on kind of the temperature in my basement at the time. But so I sometimes I'll set the floor higher than I normally would, and, just because I know it's not going to be able to get it down to 50 degrees because the basement's too warm or something.
So you could also set this to allow for diacetyl rest by raising and allowing the temperature to rise, but then at some point the natural activity stops. So then you'd have to have yet another device plugged in as a blanket around that to heat it to get up to a diacetyl rest before you go back to chilling it.
Yes, and actually I haven't done it yet, but I have found actually a couple times in the winter it's been really handy to have like basically a 2-stage controller with like a firm wrap or something like that to heat it up, and you could even, that would actually be perfect for loggers, because you could like put it in your garage in the winter when your garage is like 40 degrees and just have it raise the temperature up to 50 or whatever and do a nice lager fermentation, and not have to swap ice bottles or anything like that. So actually my very next project I'm going to do is to add basically a heat side to this, so that I can do exactly that.
Yeah.
So what I've always wanted to do is leverage the outside temperature, like have a tube, instead of the ice
Just pull the
chamber,
air, yeah.
just pull in the outside air, and maybe there's some measurement on that and some logic, but it's like, man, it's free chilling out there.
You don't have neighbors like
You
I
could
do.
totally do
They'd be drinking.
Could you,
Yeah, no, it's like, why are we paying all this money to heat the house and then doing all this stuff to like cool it back down? It's like, it's already cold. It's already missing heat out there, so you just need, like, the hard part is the exterior interface. After that, it's like totally easy. And you could probably almost have it be mostly passive. You just need like something that opens, because that cold air is gonna fall in and down.
Oh, that's true.
And you could almost do it without a fan.
See, and that's why this is so cool, because you can do experiments like that really easily. You just have to find, some servo or something to
You want to
open
drill
a
a few
vent
more
or
holes in your
whatever.
house.
Well, that too. But yeah,
close to a window, you could.
Yeah,
a little,
yeah, one of those little like window AC like
Well, yeah, I mean,
things.
Or
Yeah.
just put the whole thing outside and put an incandescent light bulb where your ice bottles are.
Now you're
Yeah.
And
Yeah,
use
you're
that
back
to blow
to-
heat and power usage.
so you said you could potentially interface it with a tilt, but it would be kind of tough.
Yeah. So you have to have like a Bluetooth gateway.
There is a project.
Yeah, is it that one
It's
that
an
uses a
ESP
Raspberry
phone.
Pi to do,
Yeah.
like, to act as like a Bluetooth gateway that will
Yep.
then, yeah.
And I was just thinking, you know, if you wanted to adjust your temperature based on your gravity, you know, you get to a certain gravity level, I wanna start ramping temperature up, and then when it gets, maybe you say when there's no change in gravity for like 3 or 4 days, start ramping
Yeah.
it down on my cold crash or something like that, you can kinda automate it that way without even having to put a ramp in. You're kinda putting a ramp in by gravity set points, but you're not
Yeah.
manually watch it.
Are you even brewing at that point?
No, and you are, because here's what you have to do, when you're in Tahiti on the beach, and your Raspberry Pi that's talking to your tilt goes down, and you gotta talk your wife through how to reset. Like, that's brewing right there, that's really what it's about.
Yeah, so open an SSH terminal, type
I don't know, he had something to do.
So would it be useful to have like a, maybe, like something that watches for a steady increase of the beer temperature, or maybe a separate probe that checks the chamber temperature for increase, or going so long with the fan not being on to like detect the power outage, basically is what I'm always worried about. Power goes out,
Yeah.
ruin the beer because it like goes up to 90 degrees.
Yeah, probably the
What do you
easiest
do
way around that.
If you're not in the house to know that the power's out, what are you really gonna do?
Call Brian Avery and have him go over your house and do things.
That's scary.
I mean, honestly,
For the beer, he
That
would do it.
causes more that could cause.
But you're not
more
using this
damage.
system if you're
Is
in
it for the good of the
Tahiti.
beer?
You can't change
Yeah,
water-
what?
So you're not using this system if you're in Tahiti because you can't change water bottles out. But
Interns.
Well, yeah.
So we got the fridge set up, you don't need it.
But if you had the
Yeah, or
fridge
if-
set up,
or
that's
if-
different.
Stop
Yeah,
fridge,
the fridge,
fridges-
the fridge
fridges
setup,
are how
or if you were doing the
normal people
heat,
do it.
the heat version of this in the winter, then,
Yeah.
then you're good.
Yeah.
So, yeah, but kind of to your point of the tilt though, kind of one of the cool things about this automation thing is you can pull in multiple devices. So it doesn't have to just be a rule that works on the fermenter. You can use a separate device like the tilt and use that as some condition in your rule, or
Or your
you could
weight scale, right?
or you could do a temperature ramp and say, hey, when the temperature reaches the current temperature of my kegerator, stop the ramp, or whatever, stuff like that. So you can kind of tie it all together, like with these automation rules. So let's see, any more questions on that? Okay. All right, that's pretty much it. So this is my YouTube channel. I'm gonna shamelessly self-promote this and put this out on all our mailing lists and Discord and all that fun stuff. This is kind of the YouTube channel.
Is that a diode hop? What is that?
Yeah, I took an LED. I'm actually kind of proud of this. I learned to use Inkscape just enough that I could take like an LED symbol and put a hop cone on it. I'm ridiculously proud of that symbol there. So.
Make some shirts.
So is it is it a light emitting diode, the arrows indicating
No,
that?
it's a lupulin emitting diode.
Yes.
There you
It's fantastic too. Goodness.
Ooh, that's good. I'm
So
good.
much
I didn't.
awesome.
Sorry, I think you had a legitimate question.
Sorry, yeah.
You liked it, you want
This, a friend of mine that lives in Minnesota, unfortunately, so he can't join the club, but he has a similar kind of engineering.
And we have somebody from
we got that guy in Florida.
Oh, that's true. We did. Yeah. Okay. Maybe I'll try to convince him. So it's a friend of mine. We've been working together for years and years, and he has a similar engineering background to me. And he brews beer. So we had the bright idea of like, hey, is there some way we can kind of tie together our electronic fiddling with brewing? And we kind of came up with this. So right now we just have one kind of project series with some kind of background videos like how to set up Home Assistant and here's how to use a breadboard if you've never used one before, stuff like that. But basically we have one project series now with like, I think it's like 5 parts that go into depth on you know, constructing the box and constructing the electronics and, you know, all that sort of thing. Our plan is to do more projects like this, like, I'm gonna hopefully add a video that shows how to add a heating side to this thing.
And, I mean, and all this stuff, right, it doesn't, like, it could apply to Jake's refrigerator. All this stuff is
Yeah.
easily adaptable to, like, all the home automation for cooling, heating, ramping.
Yeah, and actually, and the friend of mine, his kegerator is run by Home Assistant. Right now I have an Inkbird controller, but I'm gonna replace it with something very similar to this so I can do that. We're planning on adding, I think one of our next projects is gonna be doing, making keg scales, so you can actually see how much beer is left in your keg, and it'll show up on Home Assistant.
So along those lines, I'm aware of these
Yeah.
stick-on sensors that are used in RV automation for tank depth, and it uses some ultrasonic something,
Yeah,
but it's supposedly pretty good on, I'm not sure, and it works on metal, works through metal. So my mind jumped to,
Stick it on the outside.
yeah, I think it's on the outside.
Actually, yeah, I've got them on my propane tanks on my RV.
Yeah, and they work on
Yeah, you
propane
put it
tanks.
They're on the outside of the tank?
It's on the
And
outside
are
underneath,
surprisingly
and it
accurate,
shoots a
is what
beam
I've
of
heard.
ultrasonic or whatever up through the
Yeah.
outside of the canister, and it can tell you how much propane is in the,
But people are using Home Assistant on their RVs with this kind of stuff tied in, so it was like, adapted to-
I was gonna use strain gauges, but
What is this
I
device?
wasn't aware of
'Cause,
that.
you know, nothing worse than trying to. do
I don't remember the name of it, I'll look it up and send it to.
Yeah.
Yeah, but it's like a,
It's-
just like a
it's-
puck.
It's like a little puck it's got a magnet that sticks to the bottom of the propane tank. Yep.
That's what you can do.
Yeah, it's-
Tank
Vibrates
tank.
And that
Probably,
same thing,
and
you can put on a water tank.
checks out
However
the,
much-
the
on a
resonant frequency of the
decorating
tank.
tank.
How much
It'll-
liquid is
It's
probably
any liquid.
fluid
It's
is
Sure there's
amazing
depending
job, and I
upon
don't even know if
the
it's
vibration.
Like, they don't even tell you the
yeah,
temp.
there's some return time that changes.
And how would the
based on
density of the fluid not?
liquid or
Like,
Yeah, that's
I
pretty
get it,
cool.
but people are like, these
That's
things are
fancier
amazing.
than what I was gonna do.
They're like, just when you change your propane tank, don't forget to take it off and put it on the tank.
Yeah, I have a two-stage
Yeah, dude,
temperature
propane
controller,
tanks is
so I can have a
Yeah.
heating cycle and a cooling cycle. And there's two plugs, like,
Yeah,
I got it a long time ago and I had an electrical, because electricity is magic to me. Had an electrical engineer friend wire it up for me,
yeah.
and I can program it, but that's all I'm doing. I'm not digging it around in wires and shit.
Yeah, that's the hardest part of this for sure. But well, so anyway, if
I
you're
think I could.
if you're interested in projects like this, check out the YouTube channel. Right now we're kind of like gauging if anybody has any interest in crap like this. So we'll be watching, you know, views and subscribers and stuff to see if it's, you know, popular.
Well, thank you for bringing up the Home Assistant. I wasn't aware of it. I made a point
Yeah,
to
yeah.
different away from those other cloud-based snoops. And so
Mhm.
we have nothing that's connected because of that. So this is very interesting to.
Except the bugs that I planted in your house.
I only have a Nest thermometer, that's the only thing, I know it's Google thermometer, it might be Nest.
Oh, like
Google
the
on
thermostat
that,
thing.
yeah.
Yeah.
I say thermometer, I meant thermostat.
I have
Yeah,
a
that works in
Lowe's
Home Assistant.
garage door.
Does it?
opener, and that's all I have.
Pretty much
Being able to open your garage door from your cell phone, that's pretty.
Yeah, or
pretty cool.
or if you're paranoid like me, just being able to check.
Yeah.
The status of
Yeah,
your
there's like
have-
a little
if I have a
magnet
Nest-
sensor
Yeah.
that
But
tells
that's a
me
really
if it's
good one
closed.
because at 10 o'clock, if your garage door is up, you
Right.
want it to call you.
And you can make a little automation rule that would
Right.
tell you. Yeah.
Yeah.
If you have a Nest, can you get away from using their app and you would just use the Home
You
Assistant
can.
to run it?
I think Google charges like a one-time fee of like $10 to use like their API, but from then on you could just have Home Assistant totally control
Okay.
your Nest. So,
Pretty,
yes.
pretty much any home device, somebody has written a ESP home module for.
Yep.
And like, one cool thing about it is, so, like, we were talking earlier about the Chamberlain garage doors that tried to close off everything. And I have a sous vide immersion element, and they recently made their software stopped supporting the older models, because they didn't want to support the older models of these, but somebody reverse engineered the protocol for them, and there's an ESP module for that immersion element now, so you can.
So when your garage door goes up, you can start the, crank up the.
You can actually still use it from the interface on the thing,
You just
but
leave the meat in there all day while you're at work, and then it just turns on when you get home.
It's kind of like
Are you
a.
using
was
that in
meat
the
stick.
mash? Are you using that in the mash?
no, I just use that for sous vide things, like, you know,
Cookie
for
tray.
cooking, yeah.
There's actually a community of people that reverse engineer like cloud connected commercial devices, and they literally use ESP Home to like rewrite the firmware on the device so that it disconnects it from the manufacturer's cloud, and from then on it's yours for real, and it doesn't talk to. So there's a whole segment of ESP Home folks that do that. Sometimes that's a little more involved. You have to actually like get in there and solder some stuff sometimes. But like it just kind of shows like the power of this stuff. It's kind of amazing what you can do with it.
Sometimes it also exposes more features too, so like the RAT GDO garage door thing that I was talking about earlier, think about everything your garage door can do.
Is RAT an acronym?
I don't know what
It
the
stands
RAT
for
stands
Rage Against the Garage Door.
Oh, I never knew that.
Yeah, it's an awesome acronym. I love it.
So you've got a switch that opens and closes the garage door, right? That's the key thing. But your garage door opener also has a light that you can turn on and off. It also has motion sensors that check it might have a couple of them. It might have one that
What is the sensor on the door?
or the door, the safety sensor. Some of them also have one on the main panels where you walk in the garage and turn the light on. Well, RAT GDO will expose those all as individual things. So to whatever interface you're using, whether it's HomeKit or Home Assistant or whatever, it exposes like a light switch for the light can turn on and off. It exposes motion sensors, so it can, if you want to know if somebody's in your garage, like it can alert. Your regular garage door opener won't do that.
But
It could do it.
And you can start using those in automation rules in
Exactly.
the Assistant to do
Yeah.
whatever you want.
Yep.
Serve up here. Turn on catering.
Or you could use those motion sensors and be like, don't let my kids leave the garage, you know, or something, you know, whatever. You can
Or like, they went out to the garage.
Crush my children.
Override the safety.
I told them not to get more ice cream from the garage freezer, and they did. You could also put a contact sensor on your freezer.
That's actually one use case I've
Air
heard
tags
for the cake
on
scales
the
is you can
bars.
actually monitor if your kids are drinking off your cakes. Get a notification, somebody just drank one of your beers.
Somebody poured a wine.
Yeah.
Any more questions for Ken?
Fantastic.
Yep.
Yeah.
Outstanding
Awesome.
presentation, thank you.
Thank you.